All right, let's talk about transformations of functions, and you have definitely seen this before in other classes and even in this class, but we're going to formalize a few things, and the paper that I have is the same as what you have, only mine is not going to show up quite as clearly. It's not printed on plain white paper. So anyway, write the equation of the parent function, f of x, state what transformations have taken place to create g of x, and write the equation of g of x. So here's what we're going to do. Let's actually go through all of these first and write down the equation of the parent function. That should be pretty straightforward. The parent function is going to be f, and so I'm just looking at f and I'm saying, okay, what kind of equation is this? Is it linear? Clearly not. It's pretty basic questions. By the end of the whole thing, we realize this is quadratic, and this is truly x squared, just plain x squared. That's it. Nothing too crazy about that. And I know that it's x squared because I can plug in a few numbers and get some other predictable outputs out. For example, if I plug in a 1, I get a 1. If I plug in a 2, I'd get 4. So 1 squared would be 1, 2 squared would be 4, so we're good. So in a few minutes, we're going to have to write the function g based on what we did to get g. So we're going to have to write down what we did to turn this into this. It's going to be pretty straightforward on some of them. Some of them can get a little tricky. So let's just slide up to the next one and write down the parent function for this one, and that would be this guy right here. This V-shaped thing, which would be absolute value. And just to be clear, this is truly absolute value of x, and there's not a constant in front of it because, again, notice the slope here is 1. I could go over 1 and up 1. Well, up 1 over 1 if I'm talking about slope, but I also could plug in a 1 and get out a 1, which is where I was going with that in the first place. So I know the slope of this is standard. All right, g of x is something. We'll figure that out in a minute. All right, f of x here, same as the first problem, so x squared. F of x here, absolute value of x. And this one right here is one of the more obscure ones, but this is a cubic function, and it has that general cubic shape, and if I plugged in a 1, I would get out a 1. There we go. All right, here we go. We're going to figure out what we would do to f to get g. So let's start back with the first one, and I actually have printed these or typed these up on Desmos, so it's going to be a lot clearer, and we can experiment with some things to figure out what exactly we would do. So what you see on your paper is this right here. So let's go for the obvious. In order to turn f into g, we would shift the function 3 units to the right. So I'm going to write that down in a minute. And we also have this difference in the steepness of it. So notice that g, this one, the red one, is steeper than f, and I need to figure out how much steeper it is. Like, what would I have multiplied this by to stretch it and make it look like that? Now, obviously, there's the right shift, but how much did it get stretched? Here's what I like to do. So check this out. I'm not going to write on my screen, but check this out. From the vertex, if I went over 1, I'd go up 1. But from this one, if I went over 1 from the vertex, I'd have to go up 2 to land on a grid mark. So this one is stretched by a factor of 2. So we're going to write all that down. So here goes. Let's write it in green. F is shifted 3 units right, and what else? And stretched, vertically stretched. Stretched vertically by a factor, I could say scale factor, of 2. So that's what I did. So now we're going to come up with an equation for that, and you probably already know what it is, but I'm going to experiment a little bit just to drive home a few points that you might already know. So here's what I'm going to do. I'm going to come down here and I'm going to just start experimenting with y equals something, and we're going to hopefully come up with this equation. Now what I just typed was x squared. I'm going to change the color of that from red to, let's make it green. There we go. And so I'm going to want this green graph to eventually be on top of this red graph. So I'm going to have to do some stuff. Let's scale it by a factor of 2. And I'd like to think this part's obvious, but let's basically just double it. Okay, well that did stretch it. That scaled it up by a factor of 2, which makes sense. Here we go. I could go over 1 and up 2. There we go. We're on a grid mark. But I still have to shift it over 3 to the right. And most people's first guess on this, and I believe you know better, and that's okay if you don't, would be to add 3. Well, that's going to shift it up 3. So that was a bad idea. Terrible idea. Why don't we put parentheses around that, and we're going to shift it 3 by adding 3 this way. Oh no, I went the wrong direction. You know this. It's with the x lies to you. So we are going to do the opposite. There we go, that was it. So this is the equation of g, and it does match up. So let's write that down, and then let's go through the next few. So 2, and then x minus 3 squared. Okay, let's talk a little bit faster on this next one. In order to turn f into g, we had to reflect this one across the x-axis. You would probably say, like, your gut reaction might be to word it as it got flipped upside down. I hear you, you're not wrong. I'm going to word it a little more mathematically. So f is reflected across the x-axis. But clearly it's not just a perfect reflection, otherwise it would look like this. But instead it is steeper, so we're also going to say it is stretched vertically. By a factor or a scale factor of, okay, now let's figure out of what. And it's really hard to see on my paper, so I'm going to go here. Let's turn this one off, turn number 1 off, turn number 2 on. And I want to figure out exactly what that scale factor is. And this is going to be pretty straightforward. Again, the original function, you can go over 1 and up 1 and you land on the grid mark. Here, if I go over 1, I'd have to go down 3. Well, down 3 because we flipped it over or reflected across the x-axis. But I would have to go 3. So we have scaled this by a factor of 3. So that means we're going to have a 3 in the front of this thing, just like we had a 2 in front of the other one. So what I'm going to do is go ahead and start writing my final answer. So 2 and then absolute value of x, and that should be it, right? Right? Let's make sure. Let's type it. Here we go. There's that parabola from a minute ago. Let's take that out. Put an absolute value in there. Oh man, that's not it at all. I clearly need to flip that over, so I will put a negative in front. Ooh, I put a 2. Should be a 3. My fault. Sorry, what did I write? I put a 2. Oh no, no, it should be a 3. Y'all were watching the video thinking, man, he done messed up, and now it's an ugly 3. Don't body shame my 3. There we go. By the way, one more random thought. If you don't put the negative there, and you get the clever idea that you're going to put the negative here, actually it doesn't help. So notice where my cursor is, it's right in front of the x inside the absolute value. When I put a negative there, I'd still have to make it positive, so it doesn't really change anything. So that can happen sometimes, and just be careful with that. All right, that was the second one. How about we go through the other ones very, very quickly, and then formalize what we already know. So here's the third one. In order to turn this parabola into that parabola, I'm gonna list things very quickly, and then we're gonna write them down. It got shifted, translated is the technical mathematical wording. So we're going to translate it. Let's look at the vertex. This vertex translated 3 to the right, and it went up 1. And also, clearly, it's upside down. And it may not be super obvious, but it's actually skinnier. So we're going to have to figure out what that scale factor is too. There's a lot going on here. There's actually 4 things. Horizontal shift, vertical shift, reflection over the x-axis, and also it got vertically stretched. Let's figure out that vertical stretch. I could go over 1 and up 1. There's the standard. And then from the vertex of this one, I could go over 1. And then I'm going to go until I land on a grid mark, 1, 2. So it got stretched by a factor of 2. If you want to get technical, it was negative 2, which is why it's upside down. So we're going to write that down very quickly. F is shifted 3 units right. I was about to say 1 unit up. I'm not going to go there yet, and there's a reason why not. 3 units right, reflected across the x-axis, stretched vertically, by a factor of 2 and shifted up 1. Why did I save that shifting up 1 till last? I'll tell you in a second. Up 1. Okay, let's write this as an equation after we experiment with it to make sure we know what we're doing. So we want to go 3 units to the right. Here goes. There's that absolute value that's about to go away. So if we're going to take a parabola and send it to the right, we need to put the right, the 3, with the x. So minus 3, because your x lies. So far, we've got our shift to the right. And we are going to flip it over, put a negative in the front. And we're going to stretch it by a factor of 2. So we're going to multiply by negative 2 instead. And now we're going to shift it up 1. Okay, here's the reason that plus 1 is last in the way that it was worded. So a second ago on the paper, we were like, and it got shifted up 1. And I didn't put it up here with the other shifting. The reason why is because we're building to something later on in these notes where we're going to have to follow the order of operations. And if I'm looking at this, I would do parentheses first, and then exponents, which is really nothing in this context. And then I'd multiply, which takes care of the flipping it over and the stretching, and then the adding and subtracting last. So it's really a matter of order of operations. So what I just wrote is the answer for G. So negative 2 x minus 3 squared plus 1. All right, we're going to do this one without the computer, and maybe the next one too. So here we go. F is, well, clearly shifted from here to here. So let's go from vertex to vertex. 1, 2, 3, 4, 5, 6 left is shifted. 6 units left, and 2 units down. Whoops, whoops, whoops. I shouldn't put that first, or put that with that, because of the order of operations thing I just said. I'm going to mark that out. I would have used white out, but this is not white paper. I need to use, I guess, cream out. I don't know. Is that a thing? So shifted 6 units left, and it is not flipped over. It is stretched vertically by a factor of, all right, let's count. The normal would be over 1, up 1. And this one from the vertex would be over 1, and then 1, 2, 3, 4. So by a factor of 4. And then shifted down 2. Down 2. Okay, let's write it. All right, we have an absolute value that got shifted 6 units to the left. That would be x plus 6. Stretched vertically by a factor of 4, and then shifted down 2. That would be it. I could type it into the computer, but it would be right. All right, last one, cubic function, as you know. This one does not have any vertical stretch, and you can tell by doing the same thing we've been doing, over 1, up 1, that works. And from this little point where it kind of levels off, over 1, up 1. So no change in the stretching. This is all vertical and horizontal shifting. So F is shifted. All right, let's go from here to here. I'd have to go 2 units left, 2 units left. And how many up? 1, 2, 3, 4. 4 units up. Okay, that takes care of that one. All right, 2 units left. So it is a horizontal movement. That would be an X issue. When you're inside the parentheses in this context, you would go in the opposite direction because your X lies to you. So when I want to go negative, I'd put plus, but I will go up 4. Okay, all righty. Here's where this is going. We have to identify what part of the equation does what. So just very quickly, not even going to write it all down. I said I'm going to formalize it, but I'm really going to formalize it just by pointing. This number in the front determines if it flips upside down or not based on whether or not it's negative. Flips upside down, doesn't flip upside down. This number in the parentheses or in absolute value or in any other kind of grouping symbol or simply just with the X, wherever the X may be, it might be in the exponent. we're going to make that a horizontal shift, opposite sign. This is a vertical shift, and you're going to keep the sign. All those things are things you knew, but now we've sort of formalized it a little bit because as we move forward, we're going to need to be looking for this structure, and once we know this structure, we'll be able to do a little more with it.